In exactly 48 hours, something extraordinary will happen, for which NASA has been meticulously preparing. An object traveling at 137,000 miles per hour, arriving from another star system, will pass within 29 million kilometers of Mars. But here's what they are not telling. Avi Loeb from Harvard rated this object 6 out of 10 on his scale of potential alien technology, indicating 60% confidence that it is not of natural origin. And when you see photographs taken by astronomy enthusiasts, you will understand why the scientific community is in complete chaos. This object does not behave like any comet we have ever observed. It emits pure nickel without iron. This is impossible in nature. This can only happen during industrial production. Its chemical composition is 16 times more extreme than any known comet. It changed color from red to green overnight. The probability of its trajectory being random is 1 in 500. But here is where it becomes truly frightening. At the end of September, the object Tri-Atlas will disappear behind the solar disk for 2 months. We will not be able to observe it during its closest approach on October 30th. Loeb suggests that this might be done intentionally to avoid observation at the moment of its brightness or when something else happens. Some scientists believe he may have already deployed invisible preliminary probes, too small to be detected by Earth telescopes, which could reach Mars while we all focus on the main object. More than 227 observatories around the world tracked this object. They collected over 4,000 observations, and each data point makes it increasingly strange. At a weight of 33 billion tons, it shouldn't exist. The math doesn't add up. We should have found 100,000 smaller objects before stumbling upon something this size. So, what is the 3I Atlas? In the next hour, I will show you every anomaly, every leaked observation, and every theory that scientists do not want to discuss publicly. Because after October 3rd, when the Martian spacecraft direct their cameras at this object, we may finally get answers or encounter something much more troubling. If you are as curious as I am, like and comment where you are listening from, what time it is now, and the strangest thing that has ever happened to you. Chapter 1. Shocking Assessment by Avi Loeb. 6 out of 10. Avi Loeb has just done something that sparked a wave of discussion in astronomy. The Harvard astrophysicist who claimed that Oumuamua might be alien technology in 2017 has now rated the Tri-I Atlas a 6 out of 10 on his scale of potential technological origin. This is 60% confidence that he is not natural. And before you roll your eyes, understand what changed his mind. This was not speculation, but data from the James Webb Space Telescope, a very large telescope in Chile and Hubble, showing things that should not exist. Webb observed the Tri-I Atlas on August 6th and found that its gas tail consists of 95% carbon dioxide and only 5% water, which is 16 times more extreme than any known comet at such a distance from the sun. The comments should be rich in information, but this one does not meet expectations. Then VLT discovered nickel in the gas cloud. The emission lines are clear and bright, but surprisingly, there is no iron. Not a drop. Throughout the history of observing cosmic objects, nickel and iron have always been found together. They form in dying stars, expelled together in supernovae. Finding nickel without iron is like discovering smoke without fire. This does not occur in nature, but is often found in industrial production, in pure nickel alloys and components for the aerospace industry. This level corresponds to factory production, not space debris. Nickel production is increasing. When it was first discovered in July, the emission level was modest. By August, it increased 25 times. The closer it gets to the sun, the more metal evaporates. Supernovas were harshly criticized for even hinting at extraterrestrial explanations. Jason Wright from the University of Pennsylvania called his work careless. Tom Statler from NASA said it looks like a comet and behaves like a comet, but neither explains nickel without iron. No one discusses the extreme ratio of carbon dioxide or the trajectory, the likelihood of which is 1 in 500. Loeb himself admits that his technological hypothesis is largely a theoretical exercise. He says that the most likely outcome is still a natural comet, but most likely does not mean exact. And with a rating of 6 out of 10, he states there is a 40% chance we are wrong about everything. The flyby past Mars on October 3rd will provide more information. If a high-resolution camera shows a core larger than 5 kilometers, as its mass calculations suggest, then the natural explanation will collapse. In interstellar space, there aren't enough rocky materials to deliver objects of such size so frequently. Chapter 2. Amateur photographs that broke the internet. Social networks explode with what professional astronomers refuse to discuss. amateur astrophotographers share images of the Tri-Eye comet that do not resemble a comet. Instead of blurriness and diffuse glow, as expected, some photographs show structure, geometry, and clear boundaries that shouldn't be there. Michael Yeager and Gerald Raymond, two esteemed astronomy enthusiasts, captured the trigaze during a total lunar eclipse on September 7th in Namibia. The images show the object glowing green with a blue tint, clearly saturated with gas, and visible through both blue and green filters. Professional astronomers recognize these images as legitimate. However, other enthusiasts, whose names have not appeared in press releases, captured what is now called structured images. Photos spreading on Reddit, Twitter, and astronomical forums show something more solid, clearer under the gas cloud, something that looks less like a diffuse cloud and more like an object with clear edges. The professional's response is silence or immediate denial. When it comes to observation problems, motion blur, exposure artifacts, and tracking issues with the telescope are mentioned. These are indeed serious reasons, especially when it comes to photographing fast-moving objects that are thousands of times dimmer than those visible to the naked eye. Smearing and distortions are common problems. But here's what makes this situation intriguing. The Atlas telescope, which discovered the three-eyed Atlas, has only a 20-inch diameter. This is amateur-level equipment. Many high-class hobby astronomers have similar or even better gear. So why, when someone with such technology captures an unusual structure, is the reaction automatically dismissive without further investigation? On astronomy subreddits, fierce debates rage as users compare images showing classic manifestations, like developing comas and weak tails, alongside more puzzling features like compact cores, irregular shapes, and pixel patterns that defy standard scattering functions for stars or comets. Half of the commentators scream about image processing errors, while the other half demands that someone with professional equipment repeat the observations for confirmation or refutation. But this does not happen. Instead, professional astronomers engage in discussions to refute without offering verification by their own means. One of the widely circulated images on Platform X shows that the object appears to have a more compact and less blurry core than what Hubble captured. The enthusiast claimed it was taken with a 14-inch Schmidt-Cassegrain telescope and composed of 50 separate exposures, which is standard practice for deep space photography. Professional astronomers immediately began discussing atmospheric distortions, tracking drift, and chromatic aberrations. Any explanation would do, but none suggested pointing large telescopes at the same coordinates. No one offered to help verify the observations, only refusals. What makes this situation strange is that the image obtained by the Hubble telescope on July 21st showed a droplet-shaped dust shell, its glow extending towards the sun. This is official NASA data, and it has already defied expectations. The tails of comets should move behind, influenced by solar wind and radiation pressure. This one pointed forward. Professional astronomers called it interesting, puzzling, and worthy of study. When enthusiasts capture strange things during the same period, it is called user error. Then on August 27th, the Southern Telescope of Germany captured images showing the first evidence of a real anti-solar tail streaming behind an object. Thus, something changed between July and August. Either the three-eyed Atlas began to behave more like a traditional comet, or our angle of view changed enough to reveal what had always been there. Most amateur photographs claiming an unusual structure were taken from July to August, when the object showed the least resemblance to a comet. Even professional observations noted anomalies. And here is another fact that is not discussed enough. The rare NASA Sphere-X space telescope observed the three-eyed Atlas in early August and saw it as a point source. There was no blurred tail, just a dot. That's how comets look in infrared light. They demonstrate an extended emission from heated gas and dust. But Sphere-X has nothing like that, just a bright point. We observe a certain pattern. Professionals record anomalies that cannot be fully explained, while amateurs see anomalies attributed to incompetence. Both are photographing the same object through a strange window when it does not behave like a comet. The European Space Agency will capture images of the object Tri-A Atlas on October 3rd using cameras designed for photographing the surface of Mars from just a few hundred kilometers away. They will study this object from a distance of 30 million kilometers. NASA has already stated that they do not expect impressive images. It will be less than 1 pixel in their cameras. But what if enthusiasts really saw something real? What if a structure is hidden beneath the gas? Observations in October may not clarify the situation. Perhaps we need something closer, with better instruments aimed directly at this object without atmospheric interference. The truth is, that we are acting with limited information. Professional telescopes have limited time and strict observation schedules. Amateurs have more flexibility but simpler equipment, and somewhere in this gap, something unusual is happening that neither side wants to fully acknowledge. Because if the enthusiasts are right, if there is a structure that does not match the natural morphology of a comet, then we are not talking about image artifacts, but about the need to rewrite our understanding of interstellar visitors. Chapter 3. Meeting with Mars on October 3rd. What they don't tell you. In 2 days, Tri-Eye Atlas will fly 29 million kilometers from Mars. This seems like a safe distance, but here is what no one talks about. The minimum distance of orbital intersection, the closest this object approaches Mars's full orbit around the Sun, is only 2,700,000 kilometers. A scientist named Loeb called this an astonishingly precise calculation. When a physicist from Harvard uses such specific words, it's worth paying attention. A high-resolution camera aboard the Mars Reconnaissance Orbiter will capture Tri-Eye Atlas with a resolution of 30 kilometers per pixel on October 3rd. This is enough to separate the core from the surrounding cloud of dust, enough to measure the actual surface reflecting sunlight, and enough to confirm whether this object is indeed 5 kilometers in size, as recent calculations by Loeb suggest. If it is indeed that size, the explanation of a natural comet completely falls apart. Given the limited supply of rocky materials in interstellar space, we should have discovered about 100,000 smaller interstellar objects the size of Oumuamua before finding something as massive as Triangulum Atlas. But we found only 2 previous visitors. Both were tiny compared to this one. But here is where it gets really unsettling. Loeb calculated that if 3 objects called Eye Atlas deployed a preliminary probe, a small reconnaissance device moving ahead of the main object at a distance of about 30 million kilometers, this probe could reach Mars on October 3rd or within a week before that. And here is what is truly frightening. Ground-based telescopes cannot detect objects smaller than about 100 meters at a distance of up to Mars, which roughly corresponds to the size of all spacecraft ever launched by humanity. Any preliminary probe will actually be invisible to us. This idea is not as crazy as it may seem. If you were developing an interstellar mission to survey a planetary system, you wouldn't send one huge ship. You would send a mothership with smaller reconnaissance probes deployed ahead to gather data on individual planets, while the main craft followed a safe trajectory through the system. This is exactly how we would design such a mission if we had the appropriate technology. And the trajectory of the 3-Eye Atlas makes it disturbingly plausible. The object's trajectory requires only a speed adjustment of 10 to 15 kilometers per second during September to reduce the distance to Mars to 0. For a technological object, this is a trivial maneuver. For a natural comet, it is impossible. The speed of icy fragments being ejected from sublimating comets, according to data from the Webb telescope, is only about 0.4 kilometers per second, which is clearly insufficient. The Mars Express and ExoMars Trace Gas Orbiter spacecraft will also observe the 3-Eyed Atlas on October 3rd, using several instruments, high-resolution cameras, spectrometers, and particle sensors. They are intended to study the surface and atmosphere of Mars, but will be repurposed to study this object. The instruments will attempt to characterize the volatile activity of the comet and its composition from 30 million kilometers away. But there is also a secondary goal that no one talks about. The spacecraft heroists will not only photograph the 3-Eye Atlas, but will scan the surrounding space for anything that may move ahead of the main object, searching for preliminary probes. Loeb clearly suggested this in his blogs. Use HiRISE to search for objects preceding the 3-Eye Atlas that approach Mars closer than the main object. If materials from the 3-Eye Atlas reach Mars in October, materials that could not have arrived there naturally will be a sign of technology. Time also raises suspicions. The 3-Eye Atlas reaches its closest distance to Mars exactly 1 week before it disappears behind the Sun from Earth's perspective. We get one good look at Mars using spacecraft, and then the object vanishes in the solar glare for 2 months. We will only be able to observe it again in early December. If you wanted to deliver something to Mars unnoticed, this would be the perfect window. Deploy your probe during the flyby on October 3rd while ground telescopes monitor the main object. Then the mothership hides behind the Sun for 8 weeks while the probe carries out its tasks. NASA's rovers, Curiosity and Perseverance, on the surface of Mars, may also attempt to make observations, although the comet will be incredibly dim from this perspective. The best chances for detailed imaging are provided by the Mars Reconnaissance Orbiter, and the question arises, what will happen if they discover something unusual? If the probe captures an image showing several objects, unconventional maneuvers, or anything that may indicate artificial activity, what will be the protocol of actions? Will the results be made public immediately? Will additional verification be required? Will they be classified? There is no established procedure for such a scenario because no one was prepared for it. The protocols regarding the detection of extraterrestrial intelligence focus on radio signals or optical beacons rather than physical devices passing through the inner solar system. In 24 hours, we will know if amateur astronomers observe something real. We will understand whether the absence of iron in the nickel sample means what Lobb suggests, and whether the minimum overlap distance of 2,700,000 kilometers was a coincidence or a result of deliberate design. Or we will see a completely ordinary comet core, corresponding to a natural formation, and all speculations will collapse into awkwardness. In any case, October 3rd, 2025 is a date that may enter history textbooks. The day we either confirm that the trio of Eye and Atlas is an exotic, yet natural interstellar comet, or the day everything changes. Chapter 4. Nickel without iron. A very large telescope in Chile has just discovered something that should not exist in nature. From the end of July to the end of August 2025, spectroscopic observations showed that neutral nickel atoms were ejected from the trio of Atlas. The emission lines at several wavelengths were clear and unambiguous, with nickel signals from the object's surface increasing as it approached the sun. But there was not a gram of iron. Zero emission lines at the expected wavelengths where iron should have appeared. Let me explain why this is absolutely shocking. Nickel and iron are cosmic twins, formed together in the same nuclear reactions inside massive stars. When these stars explode as supernovae, nickel and iron are ejected together into space. They condense into dust grains together. They are part of asteroids and comets together. In every celestial body ever analyzed by humanity, whether meteorites that fell to Earth or samples returned from missions, nickel and iron are present in predictable proportions. Finding one without the other would be like finding hydrogen without protons. It violates the fundamental chemistry of how the universe is structured. The VLT team, led by researchers unrelated to Avi Loeb's more controversial claims, published their findings with carefully chosen wording. They suggested that nickel might originate from nickel-carbon compounds, molecules that could theoretically exist in extremely cold interstellar conditions. These compounds are volatile and decompose under ultraviolet light, releasing nickel and carbon monoxide. However, even the VLT team acknowledged that this would be a precedent. Never before has this been observed in comets in our solar system or in interstellar space. It is a purely theoretical explanation of the observation that requires clarification. This is what worsens the situation. Nickel production is unstable. When the comet Tri and Atlas were first observed at a distance of 3.9 astronomical units from the Sun in July, the nickel ejection rate was about 10 to the power of 21 atoms per second, a significant but not alarming figure. By the end of August, when it was at a distance of 2.8 astronomical units, this figure increased 25 times. 25 times more nickel is lost from the surface in just 1 month. The closer this object is to the Sun, the more sharply its metallic emissions increase, and this increase does not correspond to the smooth curves we observe in ordinary comets. It is exponential, abrupt, as if something is systematically evaporating under the growing heat. Avilo pointed out what no one else wanted to say openly. On Earth, we regularly separate nickel from iron in industrial processes. High-purity nickel is used in specialized alloys for aerospace, electronics, and batteries, generally in anything requiring specific thermal or electromagnetic properties. The signature we discover from Tri and Atlas corresponds to industrial nickel production, not natural cosmic abundances. Critics immediately began to attack this, claiming that Lowe only selects the data he likes and engages in motivated reasoning. Jason Wright from the University of Pennsylvania was particularly harsh, calling the comparison to industrial processes misleading and unscientific. But here's what critics overlook. If nickel comes from natural carbonyl compounds, then where does iron come from? Iron forms similar volatile compounds. Iron pentacarbonyl is well studied in chemistry. If conditions existed for the creation and preservation of nickel carbonyl for billions of years in interstellar space, then the same conditions would have created iron carbonyls. Both should be there, but only nickel appears. VLT observations also recorded a rapid increase in cyanide production, Hydrogen cyanide and related compounds appear in the gas cloud around Triton Atlas at rates that sharply increase as the object approaches the sun. Lowe suggested that the change in color from red to green, noted by astronomy enthusiasts, might be related to this cyanide outburst. Cyanide itself is not unusual for comets. This common carbon and nitrogen compound is found in many icy bodies, but the increasing rate and steep production curve coinciding with nickel emissions suggest that these processes are somehow related. What is truly fascinating is that it tells us about the composition of the object. If most of its mass consists of carbon dioxide in the form of ice with small traces of water, as Webb discovered, and if nickel and cyanide are released from the surface at an increasing rate, then we are dealing with chemistry that does not match anything formed in our solar system. Comets from the Oort cloud or Kuiper belt are rich in water, as they formed in an area where water ice was stable. The ratio of water to carbon dioxide reflects the temperature and composition of the protoplanetary disk from which they originated. At the 30th Atlas, the ratio is reversed. Carbon dioxide predominates, and there is very little water. This may indicate that it formed in a completely different environment around another star, or it may suggest that it is not a natural object at all. There is a third possibility that no one wants to seriously discuss. What if the 30th Atlas has a natural origin, an ancient comet from another star system, but it has traveled through interstellar space for so long that its surface chemistry has changed? Cosmic rays, collisions with interstellar dust, chemical reactions in a near absolute zero vacuum. 7 billion years of exposure could strangely affect the surface composition. It is possible that the presence of nickel without iron does indeed exist, but the explanation lies somewhere between a natural comet and an artificial object. There is a possibility we have not yet considered, because we have never studied an object of such age from such a distant location. Observations in October will help. When the 30th Atlas is captured from Mars orbit, spectroscopic data from Mars Express and ExoMars Trace Gas Orbiter will record additional emission lines, more information on nickel production, more measurements of cyanide and carbon dioxide emissions, and more constraints regarding what it is. But right now, based on the available data, the 30th Atlas is ejecting industrial-grade nickel into space, showing no iron at all, and no one has a satisfactory natural explanation for this. Chapter 5. The Disappearance Behind the Sun. At the end of September, the 30th Atlas disappears. Not destroyed, not deflected, just hidden. It passes too close to the sun from Earth's perspective to be observed. For 2 months, from the end of September to November, ground telescopes completely lose their line of sight. The object disappears in sunlight, and this is what makes this time so suspicious. The 30th Atlas reaches perihelion, its closest point to the sun, on October 30th, 2025. This is the moment when comets are most active, when solar heat causes maximum gas release, revealing the most about their composition and structure. This observation window is crucial for understanding what they truly are, and we cannot see it. The Earth will be on the opposite side of the sun. Avalop suggested that this could be a deliberate act, not random orbital mechanics, but intentional positioning. If the 30th Atlas wanted to avoid detailed observation from ground telescopes during its brightest, most active period, this trajectory achieves just that. It hides behind 150 million kilometers of scorching plasma at the most critical moment. NASA and other space agencies are trying to circumvent this circumstance. The Parker Solar Probe, orbiting close to the sun and studying the star's corona, may capture the moment when everything aligns. The Solar Heliospheric Observatory, SOHO, continuously monitors the sun for coronal mass ejections and will see the comet Tri-I Atlas. However, the SOHO cameras are designed for solar observations, not for faint comets. The object will likely be too dim against the dazzling sunlight. The moon of Jupiter, currently on the far side of the sun from Earth, is using its highly amplified antennas as a thermal shield, limiting data transmission. JUICE will attempt to observe the Tri-I Atlas in November using cameras and spectrometers, but we won't receive this data until February 26th. Months after the events. Thus, we remain in ignorance during the most critical period when October 30th occurs behind the starry veil. What might happen in these 2 months? If Tri-I Atlas is a natural object, nothing unusual will happen. It will heat up, releasing more gas, possibly breaking apart if thermal stress damages its core, and appear in December slightly smaller and less active, returning to interstellar space. But if it is not natural, and if there is any technological component, these 2 months will become the perfect window for activities we should not see. Orbit corrections, Probe deployment, trajectory adjustments, any action requiring proportional maneuvers would be obvious to observers on Earth if we could see it. Loeb calculated that a change in speed of just 10 to 15 kilometers per second in September or October could significantly alter the trajectory of Tri-I Atlas, enough to deliver cargo to Mars, Venus, or even Earth. This is impossible for a natural comet. Sublimating ice produces speed impulses of up to half a kilometer per second, but for something with an engine, that is insignificant. Another possibility is more alarming. What if the disappearance is exactly what it seems? What if Tri-I Atlas does not appear in December? What if he uses the perihelion passage to slow down and enter a long elliptical orbit around the Sun, becoming a permanent resident of the inner solar system? We won't know about this until December, when he is supposed to return. And if he doesn't appear where the calculations predict, if the orbit changes significantly, it will be a sign of propulsion, technology, intention. There is precedent for such reflections, though not among interstellar objects. In 1986, Soviet probes Vega flew past Halley's Comet and discovered something unexpected. The nucleus was significantly darker than anticipated, reflecting only 4% of the incoming sunlight. Before Vega, scientists believed that comets were bright, icy objects. However, it turned out they are incredibly dark, covered with organic compounds and dust. The ice is hidden beneath a crusty, solid surface. This discovery changed our understanding of what comets look like up close, and it was made possible by sending spacecraft for observation. Remote observations from Earth led us to completely incorrect conclusions. With the appearance of Atlas 3 times, we returned to remote observation during a critical period, drawing conclusions based on limited data and assuming we might be wrong. We won't know the truth until December 3rd, when the object emerges from behind the Sun and becomes visible to ground telescopes. Astronomy enthusiasts are already preparing. Telescopes around the world are planning observations for early December. Everyone wants to be the first to see the return of the comet, to understand if it looks different, if its activity level has changed, and if its trajectory matches predictions. If this is not the case, if Atlas exits perihelion on a different trajectory or with different characteristics, then the main astronomical community will have to seriously consider the artificial hypothesis, not as a marginal theory of one controversial scientist, but as a legitimate possibility requiring investigation. The disappearance of the object also means that we will miss possible fragmentation events. Natural comets sometimes break apart near perihelion. Thermal stress can crack the core. Internal pressure from trapped volatiles ejects chunks of the surface. We observed this with several comets that came too close to the Sun. If Atlas fragments 3 times, we will not see this process. We will only see the consequences in December. Many pieces instead of one, traces of debris alter the rotation, and fragmentation would actually support the hypothesis of natural comets. Technological objects usually do not disintegrate from solar heating unless fragmentation is controlled, and what we interpret as destruction is actually deployment. Many smaller objects detach from the main body, each moving towards its goal in the inner solar system. This scenario sounds like science fiction, but it also sounds like nickel without iron. It also sounds like perfect elliptical alignment. It also sounds like a flyby of Mars with an accuracy of 2,700,000 kilometers. Every piece of data we collect makes science fiction scenarios a little less fictional. The appearance in December will reveal something to us. Perhaps not everything, but something. Until then, we wait in the dark, hoping that the returning object is the same one that hid behind the Sun. Chapter 6. A huge, massive object weighing 33 billion tons. A new article has emerged, causing concern among astronomers. Richard Cluitt, Peter Wares, and Avi Loeb analyzed 4,022 observations of Atlas from 227 observatories worldwide from May 15th to September 23rd. They tracked the object's position with incredible precision, comparing its actual trajectory with what gravity alone predicts. And they discovered something shocking. 3 times Atlas hardly shows non-gravitational acceleration, despite the significant gas emissions detected by telescopes and the loss of hundreds of kilograms of material every second. The object's trajectory deviates less than 15 meters a day from a purely gravitational path. This indicates that it is incredibly massive, much more massive than its brightness might suggest. The math here is quite simple. When a comet releases gases, the expelled material acts like a tiny rocket engine, slightly shifting the comet off course. The degree of deviation depends on how much mass is ejected and how massive the comet itself is. Small comets with active gas emissions demonstrate significant non-gravitational acceleration, while large comets with similar emissions show less deviation. The body named Tri and Atlas emits a massive amount of gas. Telescopes recorded 129 kilograms of carbon dioxide per second, 6.6 kilograms of water, and 14 kilograms of carbon monoxide. These are significant volumes that should lead to noticeable changes in trajectory. But this does not happen. The deviation is below detection limits, indicating that the mass of the object must be colossal to withstand this rocket effect. Calculations show that the lower mass limit is 33 billion tons, 33 trillion kilograms, with a core diameter of at least 5 kilometers. This makes Tri-Atlas 3 to 5 times larger than the two previous interstellar objects, Oumuamua, which was possibly hundreds of meters in size, and Borisov, which was about a kilometer. This object is 5 times larger in diameter, equivalent to over 100 times greater volume and mass. And here lies the problem. Based on what we know about interstellar space from research on the amount of rocky and icy materials existing between stars, objects of such size must be incredibly rare. So rare that we would have to discover about 100,000 smaller interstellar visitors before encountering something as massive as Tri and Atlas. But throughout human history, we have found only 2 such objects. It feels like winning the lottery 3 times in a row. Statistically possible, but so incredible that you start to doubt if the game is rigged. A low barrier indicates an unbearable path. If Tri and Atlas were intentionally sent into the inner solar system, if their path was chosen rather than random, then the statistical problem disappears. We are not accidentally exploring interstellar populations. We are visited by something specific. Critics argue that this is absurd. They point out that our detection capabilities have significantly improved in recent years. The Atlas Observatory, which discovered Tri-I and Atlas, became fully operational only in the last decade. Before that, we simply did not search thoroughly enough. Of course, we are now finding more interstellar objects. Finally, we have telescopes capable of detecting them. This is a fair remark. The Vera Rubin Observatory, which began operations in 2025, discovered over 2,000 asteroids in just 10 hours of work. Our ability to detect dim and rapidly moving objects has significantly increased. Perhaps in the coming years, we will discover dozens of new interstellar objects, and the statistical problem will resolve itself. However, this does not explain the mass. Even with improved detection methods, even if we find more interstellar bodies, their size distribution should match expected forecasts. Many small objects, fewer medium ones, and very few large ones. This is how populations are structured in all of astronomy. Small asteroids far outnumber larger ones. However, the Object 3I Atlas disrupts this pattern. It is the largest object we have found, discovered before we catalog thousands of smaller ones that should occur much more frequently. The absence of non-gravitational acceleration also rules out certain explanations. Some scientists suggested that Tri-I Atlas could be a loose pile of debris, weakly held together by a faint gravitational field. If that were the case, gas emissions would tear it apart. The rocket forces would overcome the gravitational interaction, and the object would fragment. But it does not fragment. It is held together despite significant mass loss. This requires either a solid cohesive core or something that holds it together more effectively than gravity itself. Observations of Mars on October 3rd may resolve the question of size. If a high-risk approach can separate the core from the dust cloud and measure how much light is actually reflected from the solid surface compared to what is scattered by surrounding particles, we will obtain a more accurate estimate of the true diameter of the core. If it turns out to be more than 5 kilometers, a natural explanation will become impossible. There is another possibility that has not received proper attention. What if the 3I Atlas is surrounded by a large dispersed cloud of very fine dust, and most of the brightness we see comes from this dust rather than the core itself? In that case, the core could be much smaller, and the mass calculations would be incorrect. But the Webb and Sphere X were observing in the infrared range. Infrared light penetrates dust, revealing solid surfaces. Sphere X saw 3I Atlas as a point source rather than an extended cloud. This indicates that there is no huge dust shell around, hiding a small core. What we see is mainly the object itself. Thus, we return to a core 5 kilometers in size with a mass of at least 33 billion tons. Exhibiting almost zero non-gravitational acceleration despite powerful gas emissions. an object that statistically should not exist, moving on a trajectory with a 1 in 500 chance. Data continues to accumulate. Each new observation makes the natural explanation slightly less convincing, not impossible, but increasingly contrived, requiring more special conditions, more coincidences, and unprecedented circumstances.